This is FlappyBoid Chapter 6. So we're finally going to start to make what is going to feel like a real game for the first time. We're going to start moving the pipes so that the player has something to dodge. Ultimately, what we're going to do with the game is make these pipes move randomly up and down, but we don't want to tackle too many things at the same time since we're new to CRYENGINE. So the first thing we're going to do is just get them moving horizontally. And since we have a finite number of pipes, but we want them to appear infinite or many more than 4, what we're going to do is move them until they're off camera and then jump back to some kind of starting position. So you notice that I've kept the math really simple here. I've spaced these pipes out by 15-meter increments. So what I'm planning to do is to move each of the pipes to the left until it's 15 meters past the ball over here, which would be at 515 on the x-axis. That'll make it off camera, and at that point I'm going to just jump it back to over here. So let's think about where this needs to be. If this pipe has gone from here to here, that's 15 meters. And if it's gone from here to here, another 15 meters, it's moved a total of 30. That means that all of the rest of these pipes have also moved 30 meters. So the first time we want to spawn a pipe back to the starting position, that means that this pipe will have come to this place. It will have moved 30 meters. So the first available slot is where this third pipe is, which, if we select the master pipe, we can see happens to be at 455 on the x-axis. Well, we could hard code these numbers, move to 515 on x, jump back to 455 on x, but hard coding numbers inside of your game mechanics, whether it's a visual script or code, is not a great practice. It's not so easy to make changes, and it's just generally not a good practice. So what I'm going to do is just create placeholder entities that are invisible, that are sort of our starting gate and our ending gate. And I'm going to use that same AI tag point entity that we've been using to house the flowgraph script. One thing I'm going to do before we get started here is I'm going to freeze this background box so I don't accidentally keep selecting it. Since I'm mostly looking at this frontal view, it's very hard not to select it when I'm trying to select pipes and score triggers and etc. So I'm going to use the freeze column right here. You'll see this little pencil goes gray, and now I can't accidentally select it. The first thing I'm going to do is create this sort of target endpoint. So I'm going to come back here and find my AI tag point, and I'm going to use this trick of clicking on top of an existing entity so it kind of gets close to where I want it instead of ending up on the terrain way in the background. And then I'm just going to use the position and mathematically put it exactly where I want it. And then we need to think a little bit carefully here. It's at the same Z position as the ball, but if you remember, if you look at the pipes, the pivot is right here. And since we have a gap between the top and bottom pipes of 8 meters total, that means that the bottom pipe is not at 100 meters. It's at 96 meters, which you can see right here. And the top pipe, of course, is at 104. So if I want to move the pipe straight across, I'm not dealing with up and down yet, I need to move it from 96Z to 96Z. So I'm actually going to push this AI tag point down to 96. Since what we're moving is the bottom pipe, this is the master for all these linked objects, I want to make sure it's at the same Z position. I'm going to give this thing a name, and I'm just going to call it AI end, because it's the end of the move. And then I'm going to do a similar thing, and right back here, I'm going to add another one of these for our start position, or our spawn position, you could think of it as. And that's 455, 500, and again, 96. And I'm going to call this one AI start, or whatever is meaningful to you. So we have these entities, and that'll make it really easy to use their position as the targets for the movements in both directions. And now we're ready to start with our flow graph. I know the first thing I'm going to want to move is my bottom pipe, so I'm going to go ahead and select it and switch over to flow graph. And while I could put this flow graph anywhere, I could put it in the main flow graph. Because I'm using this script to actually move the pipe, I want to attach the script directly to the pipe. It will make it really easy to reference the pipe as the parent or the owner of the script, and it'll make it really easy to copy that same logic to these other pipes without having to do any extra coding. So I'm going to right-click on the bottom pipe and say Create Flow Graph. I'm going to call this folder Pipe Movement. And as I mentioned before, if flow graph is already open, it's not going to update this tree automatically. So right-click on it and say Reload Graph List. There's my pipe movement folder, and there's my first entity, pipe 1 bottom. So remember the W questions. When do I want this to begin? Well, presuming I want to do it on game start, I'm going to begin with that. I'm going to use the right-click shortcut and add a start node. What do I want to happen? Well, I want to move this entity. If we scroll down here to the movement folder, we have this Move Entity To node. What do we want to move? Well, we want to move the pipe, and the pipe happens to be the owner of the script. So I'm going to show you a new trick. If I right-click on Choose Entity, instead of saying Assign Selected Entity, I'm going to choose Assign Graph Entity. And you'll note that when I did choose Assign Selected Entity, what it ended up putting here was not the name of the pipe, but something called Graph Entity. And that simply means the entity to which the FlowGraph script is attached. Assign Graph Entity and Assign Selected Entity do the exact same thing. This is really useful because we can copy this logic to these other pipes, and since it doesn't reference specifically the bottom pipe, but simply the entity that owns the graph, I don't have to reassign entities to make the logic work. So we've told it what to do and when to do it. Of course, we actually need to start the movement, and we need to give it some kind of speed. Later in the game, we're going to dynamically update and increase this speed every time the player scores a point. I'm going to start with a value of 5 meters per second. Next thing is, where am I moving to? So here I need to get the position of my target here. And I only need to do this once. I don't need to query the position of AI end every single frame of the game. So I don't want to use entity position. You'll remember that there's no get trigger here. That means it's asking every frame of the game, where's that entity? Where's that entity? And that's a big waste of resources. Instead, I want to use get position. So since I already know the name of the node, I'm just going to press the Q key and just type get pause and hit enter, and there is the node that I need. I need to make a bit of space here. When the game starts, I'm going to go ahead and retrieve the position of the entity. So I've told it when to do it. I need to tell it what to ask about, and that is my AI end position. I'm going to select it in the Level Explorer because it's a little easier than selecting it here with all this stuff on top of each other. Right-click and assign the selected entity. Now that I have its position, I'm going to feed that as the destination by dragging from this node to this node. Now before we go in and take a look at the pipe movement, this is a good time to check what our Flappy Cam is seeing and make sure that it looks okay. So I'm going to switch to that view. My camera looks like this. If your camera isn't in exactly the right position, remember that you can switch to the view here, and you can adjust it by selecting it here in my Level Explorer, and then drag or adjust these values. I've ended up putting my camera at 485 on the x-axis and 520 on the y-axis, and of course dead center on the z at 100. You may need to go ahead and adjust that. The tricky part about this is you also have to remember to match these offset values, the difference between the position of the bird and the position of the camera, here in my Camera Follows Player flow graph. So you can see my values are out of date, and I need to actually make this 15 and 20, like that. I'm going to switch back to my default camera, F11 for full screen and save, Control G to play, and it looks like my X value needs to be negative. I've done my math wrong, so I'm going to try minus 15, like this, F11, and there we go. And for the first time, I start to see what looks like the game, and I can see right away that I have a problem, which is that the jump key, I'm just pressing the spacebar once, my jump key is way too strong. So I need to adjust that value now that I can actually see the pipe moving towards me and the gap that I have to go through. So let's go back to our flow graph and to my jump, and we'd need to do some experimentation. Having done this before, I know that a value of 80 is going to work pretty well, so you can go ahead and try that. If you've chosen a different size pipe or a different size gap or different spacing between the pipes, you may want to choose a different value. F11 and test, and now I can jump and pretty easily navigate the gap in the pipes for the first time. Now the next thing is, the Flappy Cam position that I've set up actually doesn't let me see whether my pipe is coming over here to 15 meters to the left of the ball and then stopping. So I'm going to temporarily create a sort of a debugging camera. So what I'm going to do is simply pull back this camera a little bit so I can see my AI endpoint, and a little bit more so I can see where I'm going to send it back to here. And I'm going to create a temporary debugging camera from this view. Same trick I've been doing in the Perspective Viewport's camera menu. create camera from current view. I'm going to call this camera debug. I may already have a camera debug. Yes, I do. So I'm going to call it camera debug front. And just to keep things organized, I'm going to move this into my cameras layer. And I'm going to go ahead and temporarily assign that as my camera. So instead of Flappy Cam, I'm going to assign that, come back to full screen and test. And now I can clearly see what's going on with my debug camera. And when it gets to 15 meters over there, it should just stop. Perfect. So now's a good time to analyze a problem that I challenged you with quite a while ago, which is, why is my bird continuing to move to the left? I can clearly see that it's drifting to the left, drifting to the left, drifting to the left. And the reason is there is wind. As I said, the engine simulates real-world forces and has physics, and it so happens that there is a default wind value, and we're going to need to turn that off. So if you come to your level settings, you'll find this under Tools, Level Editor, Level Settings. And if you come down here to Environment State, the first property there is Wind Vector, and you'll see that the default value happens to be along this x-axis in this direction, so it's pushing our bird steadily to the left. So we're just going to change that to 0. Now if we go back and test again, we should be able to keep our Flappy perfectly in position and just endlessly jump up and fall down. Now that we have our pipe moving right to left successfully, it's time to set up the nodes to send it back to the starting position. And of course we want that to happen instantly. So we're not going to use a move entity to node. We're going to use something called beam entity. It might help you remember it if you think about Star Trek, Beam Me Up Scotty, except it's much faster than it took to go from one place to another on that show. First of all, I'm going to zoom out here, go back to my pipe movement graph. And again, we're building our logic left to right. So we've gotten our target position for the movement. We've done our move. And here's where we need to be very careful and use these tooltips to learn about what these nodes do. So you'll see there's a couple of likely looking candidates to trigger our beaming back to the start position. There's stop, there's finish, and there's done. Stop gets triggered if the stop input is triggered. And when the player dies, we are going to want to stop these movements suddenly. Finish triggers if this move is successful, if it actually reaches the destination that we fed it to. So that sounds pretty likely. And finally, done. And done doesn't tell us anything here, which is not very reassuring. So since this tells us that it only gets triggered if the destination is reached, whereas this sort of implies that it gets triggered if this movement stops for any reason. The only time we want to restart our game loop and send the pipe back to the starting position is if it successfully reached its destination. So we're going to use this node. So I'm going to drag the beam entity node onto the graph, which is in the entity folder. And on successful finish, I want to go ahead and initiate that beam. As usual, I need a destination. So since we already put our AI start here to help us navigate, I'm going to grab that thing. And I'm actually going to copy this get position node and just paste it and duplicate it. So again, on the start of the game, I'm going to go ahead and grab the position of AI start so that I have it. And once I have it, I've got it. I don't need to keep querying it over and over again because that AI start node is never going to move. I'm going to feed that as the position. And the last thing is, of course, I have to tell it what to move, and that's going to be the graph entity, the pipe to which this flow graph is actually attached. And now we need to loop this whole thing. We need to go back and trigger this movement all over again. And the problem here, as you know, is that we can't have multiple outputs into one input. So we need to insert a logic any gate. So I'm going to right-click on this, insert my logic any. So I keep this mapped the way it is. Here I might want to move things around a little bit, maybe move these up a bit. And then I'm just going to feed my done over here to one of these other inputs. This is a fairly simple graph so far, but I'm going to show you a little trick. When you're zoomed in and you're trying to drag something across a long distance and you get stuck because it doesn't scroll automatically, keep your left mouse button down so you're in the process of connecting, and then use your right mouse button at the same time to pan the graph, to drag it around. And then you can let go of that and then complete your connection. We can collapse this just to the used inputs and make it a little neater, something like that. And neaten this up a little bit. Same thing here. And there is our game loop. Think it's looking pretty complete. I don't know. I'm going to go ahead and put my comment box around it. Give it a little more space. Before I test, I want to get these other pipes out of the way because when this first one beams back to this position, they're going to be literally on top of each other. You might have noticed that the approach I'm taking here is to make sure that this code is perfect before I start copying it to the other three pipes, because it's going to be exactly the same. So all I'm going to do is come down here to my pipes group. Let me collapse this layer. And here's a little thing that I'm not so crazy about in the Level Explorer, that if you hide a parent, it doesn't also hide the children. So unfortunately, we do have to open all of these, but I can click and just drag and hide all of these very quickly. And now we're ready to test. F11, Control G, move, 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 jump, try not to die, and then should instantly recycle back to there and just continue the movement, and that loop will happen over and over again. Now is probably a good time to tweak our Flappy Cam and make sure that we're not seeing the disappearance of the pipe or the respawning of the pipe from that particular position. So let's go back to our main flow graph here and reactivate our Flappy Cam as our camera, which I put in the cameras layer instead of my debug camera. There we go. And let's test this again and just see how things are actually looking. Should go off screen, we shouldn't see it disappear, and we shouldn't see it reappear, it should just float back into view. So things are looking pretty good. I'll know better once I get all four sets of pipes, whether I need to further adjust the position of that camera. So next, let's just take our pipe movement graph, and I'm simply going to copy it with Control C. I'm going to show my other pipe entities again. I'm going to go to pipe number 2 bottom, which is my master for this little pipe set, and create another flow graph. I'm going to use the same group, the same folder. I don't need to make a new one. And there it is here. And this time it does refresh it automatically since I wasn't creating a new group. And then I'm simply going to paste with links into here. And here's where our graph entity really saves the day, because it's still referring to a pipe not by its entity ID, but just as whatever that entity is that happens to hold this graph. So I don't have to change any logic at all. I don't have to reassign any new entity IDs. I'm going to repeat this same thing for pipes 3 and 4. Paste again. Control V is paste with links, by the way, so I don't have to necessarily use that menu. One more time in pipe 4, and there I'm good to go. Okay, we're ready for a full test. Save, F11. We should have 4 sets of pipes moving straight across and endlessly recycling. And the spacing should appear perfectly even. We shouldn't see anything spawning on camera. And things are looking good. Not a particularly exciting game, but that's not the important thing. This is what we can consider the cake, the code, the game mechanics, the flow graph script. We get that working, then we can make it sexy later with moving the pipes up and down and adding particle effects and scoring stars. That's all sort of cosmetic, but the game mechanics are our main concern here. And that's it for Chapter 6, Pipe Movement.